Okay, here's section 1.3. We're going to start getting into trigonometry stuff, where we start talking about sines, cosines, and tangents. Most of you guys, we talked about this on day one, have heard of SOHCAHTOA, right? Where we can take a triangle, as long as it is a right triangle, and we can set up different ratios for the sides using sine, cosine, and tangent, where sine of your angle is equal to your opposite side over your hypotenuse, opposite over hypotenuse, or your cosine of your angle is equal to your adjacent side over your hypotenuse, or the last one, tangent of your angle is equal to opposite over adjacent. Okay, SOHCAHTOA. If you can remember that from maybe your geometry class, if we look over here at this angle, we have this angle in standard position. Here's our angle. They've labeled the sides here Y, X, and R. If I ask you to figure out the sine of this angle, remember, if you can remember SOHCAHTOA, sine is so opposite over hypotenuse. If this is my angle, angle theta, which side is opposite of that angle? Side Y, right? And then which side would be my hypotenuse if this is my right angle? Side R. So that means sine of my angle is Y over R. So then what if I asked you to set me up an equation, a ratio for cosine? Cosine, remember, is SOHCAH is adjacent over hypotenuse. So which side would be adjacent? Which side would be the hypotenuse? And so what would your fraction look like? You would end up getting X over R. Okay. The last one that we're used to is tangent. Finishing off our SOHCAHTOA, tangent would be, TOA would be opposite over adjacent. So which side is opposite? Which side is adjacent? You would end up getting the ratio or the fraction Y over X. If you can get me these three ratios, you should be able to get me the other three ratios. Do you see any similarities between the two groups? Anybody notice that tangent and cotangent are flip-flopped? Anybody notice that cosine and secant are flip-flopped? And the last one, did you notice sine and cosecant are flip-flopped? If you can figure out what your sine, cosine, and tangent are, then you should be able to figure out the other three by just simply flip-flopping them. They're called reciprocals of each other. If you can find sine, cosine, and tangent, you should be able to find cotangent, secant, and cosecant by just flipping them. Tangent and cotangent are reciprocals of each other. Sine and cosecant are reciprocals of each other. And cosine and secant are always reciprocals of each other. Okay? Simply just flipping them upside down. Okay? All right, make sure you know your SOHCAHTOA. We're going to do a few problems here. Here's example number 1. It says to find all 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant, find all 6 of them. If theta is in standard position and point -2, 3 is on its terminal side. So I know that the angle is in standard position. He's got to be here, and he has a point -2, 3 on its terminal side. So he ends by going through that point. So here's my picture. Before I can do sine, cosine, and tangent, though, don't I need a right triangle? Don't I need an opposite and an adjacent and a hypotenuse? So let's figure out how we're going to draw our triangles. okay? If I end up, so I'm going to go actually put a new page in here. If I have a coordinate plane and my angle ends up in this quadrant, I'm simply going to drop down and make my right angle where our theta ends up being right there, always, okay? If my angle ends up in quadrant 2, then in order for me to make a right triangle, I'm going to drop down my line, make my right angle here, which means theta is there. If my angle ends up in quadrant 3, I'm going to go up to make my right angle, which means theta is here. Last one, if I end up in quadrant 4, I'm going to go up to make my right angle, which means theta is here. So how are we going to remember that? Well, when you go to make your right angle, I always drop down or up to where the x-axis is. So I'm going to drop down to the x-axis. I'm going to drop down to the x-axis. I'm going to go up to the x-axis. I'm going to go up to the x-axis. Your angles and your triangles should always look like this. There's no other possibility. Okay? Then your angle is always the angle in between your x-axis and your other ray. So here. Between the x-axis and your other ray. So right here. Between your x-axis and your other ray. So right here. Between your x-axis and your other ray. So right here. Okay? It's huge to make sure that you know how to draw the picture right. If your picture is wrong, the whole rest of the problem is going to be wrong. So it's important that you know how to draw the picture right. So if we go back to this picture, we don't have a right triangle. We need to make our own right triangle, remember, by dropping either down or up till we get to the x-axis. So my right triangle is going to end up looking like this, where this angle between my x-axis and my ray is going to be my angle. That's going to be my angle for my triangle. So, do we know any of these sides? Well, I know I went over 2, or negative 2 because I went left, and I went up 3, so positive 3 here. If I want to find the sine of theta, if this is theta, this angle right here, I want opposite over hypotenuse. From that angle theta, which side is opposite of theta? Isn't that the side 3? And which side is hypotenuse? Oh, it's missing, isn't it? So we've got to figure out what that hypotenuse is. If I know that this side is negative 2 and this side is positive 3, how am I going to find the third side of my right triangle? I do Pythagorean theorem. A squared plus b squared equals c squared. So my c, or my hypotenuse, would be the square root of 13. So now I know that my opposite side is 3, and my hypotenuse is the square root of 13. The sine of theta would be 3 over rad 13. Normally we would rationalize our denominators. I'm going to go ahead and have you guys keep it like that though for now. Okay? So what about cosine? What about cosine of theta? If I want cosine, I want SOHCA. Remember, I want adjacent over hypotenuse. Which side would be adjacent to this angle? Negative 2. Which side would be hypotenuse then? Rad 13. So cosine is negative 2 over rad 13. Let's keep going. Let's do tangent. Tangent is SOHCA TOA, opposite over adjacent. Which side's opposite? 3. And which side is adjacent? Negative 2. So tangent is negative 3/2. Okay? All right. So we said before that if you can get the first 3, hopefully you can get the last 3 by simply just taking your 3 and flipping them, taking the reciprocal. Remember, tangent and cotangent go together. So if tangent is 3 over negative 2, that means cotangent is Negative 2 over 3. Easy enough, right? By just taking it and flipping it. We know that secant and cosine are reciprocals of each other. So if cosine is negative 2 over rad 13, then secant is going to be rad 13 over negative 2. And so my last one, cosecant and sine are reciprocals of each other. So cosecant would be rad 13 over 3. Okay? We're going to be doing lots of stuff with sines, cosines, tangent, all of these different trig functions. So please make sure that you know your SOHCAHTOA. You can find your sides of your triangle, and then you can set up your little fraction. Okay? One other thing I wanted to discuss with you, we're going to be talking a lot about making sure our answers are positive and negative, so we have the right signs. If you remember this, all students take calc. All students take calc. What this means is that all trig functions should be positive in this quadrant, because your x's are always positive and your y's are always positive, so no matter what combination, you should always be positive. Over in this quadrant, quadrant 2, sine is positive. Only sine is positive. Your other trig function should be negative. Let's double check that. Go back to our last example. We were in that quadrant, weren't we? Was our sine positive? And were all of our other functions negative? And that's what they should be, right? Only sine should be positive when you're in that quadrant. That means in this quadrant, tangent should be positive only. Sine should be negative, cosine should be negative, but tangent should always be positive. And in this quadrant, cosine should always be positive. All positive, sine positive, tangent positive, cosine positive. All students take calc. If you can remember that, it'll help quickly make sure that you have your signs the right way, whether they're supposed to be positive or negative. Okay? Let's do another one. Let's look at this one. It says find the sine and the cosine of a 45-degree angle. So let's draw it first. I always like to look at a picture so I can figure out where my triangle is and what it looks like. I'm in standard position and I'm at 45 degrees, so about right here. If this is my angle, then this is what my right triangle should end up looking like, right? I know it's an angle of 45 degrees. I know I just dropped down and made a right angle there. So look what I just made. Didn't I just make a 45, 45, 90 triangle? Because it doesn't give me any sides. But in a 45, 45, 90, or even a 30, 60, 90, it shouldn't matter what my sides are. When I do a sine and a cosine, I end up getting the same answer. For example, you know it's a 45, 45, 90, so these two sides should be the same. So if I told you that this side was 1, then shouldn't this side also be 1? And if those two sides are 1, then across to my 90 would be 1 rad 2. Remember that? So if I go to do a sine ratio, sine is opposite over hypotenuse, what would be my side opposite of my right angle? 1, right? What would be my hypotenuse? Rad 2? I end up getting 1 over rad 2. What if, though, you didn't choose 1s? What if you chose to say that this was 2? If this is 2, then what's this side over here on the other side of the 45? 2? And across my 90 would be 2 rad 2. So then if I go to set up my sine ratio again, I would have opposite over hypotenuse. If I reduce those, what do I end up getting? Don't I end up getting the same thing, 1 over rad 2? So if you have a 45, 45, 90, or a 30, 60, 90, it should not matter what units you choose, what number you choose, you should end up getting the same answer either way. So what about cosine? Cosine is adjacent over hypotenuse. My adjacent side is 2. My hypotenuse is 2 rad 2. Or if I reduce, I end up getting 1 over rad 2. Okay? So it doesn't matter what the units are. You should end up getting the same answer ratio in the end. Okay? All right, I'm going to go ahead and skip this one, skip B. Let's do our last example in this section. Let's do example number 3. Okay? Number 3 says, find sine of theta, or if sine of theta is negative 5 over 13, and theta terminates in quadrant 3, I need you to find cosine and tangent. So they give us sine, they want us to find cosine and tangent. Okay? Let's again first draw our picture. It tells me here that theta is in quadrant 3. So let's draw that picture first. I know I always need to start here, and I need to end in quadrant 3, which would be down here somewhere. If I'm doing sine, cosine, and tangent though, I need a triangle. So will you draw where your right triangle would be? Remember, I'm always going to go up or down until I hit the x-axis. So in this case, I'm going to go up, and that's where my right angle is going to be, which means theta is going to be this angle inside here, next to the x-axis. So now that I have my right triangle, let's go ahead and label it with a little bit more information. It also tells me, the sides being in quadrant 3, it tells me that the sine of this angle is negative 5 over 13. If this is my sine, and sine is opposite over hypotenuse, then don't I know 2 of my sides? Don't I know that the opposite side is negative 5, and the hypotenuse side is 13? So can I label that on my picture? If this is theta, and the opposite side of theta is negative 5, can I put my negative 5 there? And if my hypotenuse is supposed to be 13, can I put my 13 here? So if I know that this side is negative 5, and this side is 13, how am I going to figure out what my third side of my right triangle is? Pythagorean theorem, right? Let's go ahead and do it. I have an a squared plus b squared equals c squared. (25) plus b squared equals 169. I'm going to subtract my 25 over. And end up getting 144. Remember to take the square root, and I get b equals 12. That means this side of my triangle is 12. No, that's not right. What's wrong with it? Look at it carefully. What's wrong with my 12? What should it be? Shouldn't it be negative 12? Why? Well, if I'm going down 5, that's why he's negative. Well, if I'm going left 12, shouldn't he also be negative? Making sure that you're careful with your signs. Okay? So now that I have my 3 sides of my triangle labeled, can we go now and answer the question for cosine and tangent? If I want to find cosine of theta, cosine is so cos adjacent over hypotenuse, which side is adjacent to angle theta? Negative 12, which side is hypotenuse? 13. So cosine of theta is negative 12 over 13. Let's do tangent. Tangent is TOA is opposite over adjacent. Which side is opposite of theta? Negative 5. Which side is adjacent? Negative 12. So tangent, if I have 2 negatives, doesn't that really give me a positive 5/12? So now I can find all my trig functions. If they give me 1, I should be able to find all of them. Okay? Let's also go back and make sure that my signs are the right way. Do you remember this? All students take calc. If I end up in this quadrant, then who's supposed to be positive? Isn't tangent supposed to be positive? Well, in our answer, is he positive? Yep. Is everybody else negative? Sine and cosine? So I know for sure that I have my signs correctly because I can quickly test it with my letters. All students take calc. Okay? Make sure your signs are the right way. Don't forget to be careful with your negative if you're going left or negative if you're going down, because that will mess up your answers in the end. Okay? All right. I need you to make sure that you practice this good stuff, this SOHCAHTOA stuff, because we'll be using it the whole time. If you will do your 1.3 worksheet for homework tonight.